This will be especially important on encryption as well, because encryption compared to decompression is a lot more CPU intensive. And allow us, with this, the infrastructure we need to add here, it should allow us to then do a follow-on project, which is to say take buffers that are in the ARC, our adaptive replacement cache, and as they sort of age and aren't used, compress them in memory and still keep them around and then discard them later if they're really not used for a long time. So again, conserve kernel memory.
So now I want to tell you about something that some of you may have heard of before, but it's still relatively new in its deployment and pretty important, which is using ZFS to make hybrid storage pools. There's been a lot of talk about Flash in the storage industry, and we sort of take the view that the way most people are using Flash is actually really stupid. In that, if you think of Flash as just a very expensive disk drive, then you're going to pay a lot of money for it and not get that much out of it. What you want to do is you want to think of Flash as another tier in the memory hierarchy, in the same way that you have registers and L1 cache and E cache and DRAM and eventually disk. You think of Flash as being somewhere between DRAM and disk, both in its cost and its performance.
Yeah. So there are really two ways that a file system would use this. One is on the read side, and the other is on the write side. So the write side is what we would call a fast log disk. Is there a separate slide in there, or is this?
Yeah.
Okay, so, and on the read side is what you want to do is to have the SSD act as sort of a second level cache or a second level ARC for data that you want to cache, but you just don't have enough memory to keep it around, even though the statistics indicate, yeah, it probably might not be a bad idea to keep it around. So the L2ARC, invented by Mr. Brendan Gregg here, does exactly that. Is it takes some stuff that sort of ages off the end of the ARC, migrates it to the level 2 ARC, the SSD, and keeps some structures around in memory so that if a request comes in, instead of having to wait several milliseconds to bring that up off disk, is you just wait a couple, few hundred microseconds to get it off the SSD.
And there's another important distinction there, which is that not all Flash is created equal, in the sense that you'll hear people talk about enterprise grade and consumer grade. And the distinction typically falls along the lines of whether you have single level cell or multi-level cell, and also to what extent you have any kind of acceleration for it in the form of, because Flash can be fairly slow to write. So typically you'll have associated with your Flash a little bit of DRAM, supercapacitor or battery or something, and a little controller that then takes the stuff that you write in the DRAM and gets it out to Flash. The thing is, whether you need that or not depends on how reliable you need the Flash to be. In the case of a log device where you're committing transactions, that does need to be super reliable. So you're willing to pay the extra price for enterprise-grade Flash.
And it actually has to be very fast, because for a log device, you can't acknowledge the write until it actually is programmed into the Flash cells itself.
Yep.
So it's important for it to be both fast and very, very reliable in that regard.
Yep. On the other end of the spectrum, though, when you're doing cache devices, the multi-level cells, which are less reliable, don't sustain as many of the write array cycles before wearing out,
And cheaper.
and are much cheaper, those are perfect for a cache, because the properties of a cache for us are that, first of all, it's just a cache. So if you read from it and the data is wrong, and of course we always checksum it, if you read it and the data is wrong, that's okay. You just go to disk and you can get the real version of the data. So it's okay if it's a little bit flaky. We want it to be really big, and it doesn't have to be super fast at writes, because the way the L2ARC uses Flash for this purpose is it uses it as an eviction cache for DRAM, meaning that of all the stuff that we keep cached in memory, as eventually memory gets full, and then you say, gee, I want to add one new thing, and in order to do that, I have to kick something else out. So you have this algorithm that assesses what's the least valuable thing based on the ARC algorithm. But of course, it still probably has some value. It's just less than the others at that point. So rather than just throw it away, we then take the things that are most recently evicted from the ARC, write that out to level 2 ARC. Those writes, because they are nice and big, bulk I/O, and not terribly time sensitive, MLC is a perfect medium to use.
Yep.
And then the key at the bottom there is that you can then have much lower power, higher capacity drives for your primary storage because you're using flash to get performance. And
Yeah, so here's an experiment that Brendan and the Fishworks guys did sometime early last year, I believe, which is they said, all right, let's sort of try this out, and because just comparing performance is never all that interesting, they said, all right, let's compare price performance as well. So what they did was say, we have a fixed number of dollars. Let's buy 2 storage configurations of that. One is sort of the traditional, we'll buy a few low capacity, high performance, regular old spinny disk drives, and we'll benchmark that. In the other configuration, we'll buy 5 high capacity, low power, low performance disk drives, and add to that a write cache and a read cache. And then we'll benchmark these 2 that are basically within epsilon the same cost, take the same number of drive bays, and we'll see how the performance and other characteristics vary as we benchmark them.
that sounds fascinating, Bill. How did it come out?
Oh, it came out great. So for the given configuration there, what we found was that on the write IOPS, it's plus 11%, so a little bit better, but not a lot. And that's because of the write cache that lowered the latency of a lot of these, but that was sort of counterbalanced by the fact that eventually all the data has to go to the disk drives, which are slower in terms of performance. So the lower latency of the write cache was sort of offset a little bit by the lower performance of the disk drives. And for the read side, however, because we were able to cache a lot more on that level 2 ARC device than we could ever fit in memory, it just really shot up the amount of read I/O that we could perform by a factor of over 3. As I said before, cost is about the same. The other interesting thing is that those 10K RPM disk drives, and the lower capacity ones at that, consume a lot more power than the high capacity, low RPM drives. And the flash drives, again, relatively speaking, consume almost nothing. So the power was reduced by a factor of almost 5. And the most surprising part about this is you pay the same price, it performs better, uses less power. Not only that, you get 2x the capacity, because the low power, low RPM disk drives are so much higher capacity than the fast and little spinny drives that in addition to all the other benefits you get, you also get to store more stuff. So what's not to like?
Indeed. Well, here's something not to like. Is user quotas. So this is one of those cases where we had a plan and we hoped that the world would embrace it, and they just kind of didn't. And the plan was that the way we're going to do quotas in the new world is that instead of having sort of user quotas and group quotas, then what you would do is in a situation where you have, say, a university environment, lots of students, because we can support lots of file systems in a pool, you just create one file system per user, and then the quotas are actually on the file systems. And there's a lot of things that are simplified by that model. Some people have actually adopted that and been very happy with it. We're among them. But we still get a bunch of customers who say, I'm trying to do 10,000 or 100,000 people, and they've tried this model and it doesn't work for them. And basically the reason it doesn't work is that nothing to do with ZFS and everything to do with all the tools that actually surround it, right? When you say, DF and it turns into DF pipe to more, right? There's a lot of administrative practices that are harder because you're not accustomed to dealing with that amount of data. There's a lot of user level tools and scripts that don't scale just performance-wise to that amount of stuff. Hopefully, eventually that'll all get fixed, but a lot of that is beyond our control. And in the interim, this really was a pain point for a lot of folks who are otherwise itching to deploy ZFS, but they said, no, we've got to have classic quotas.
Yeah, and of course, one of the problems with that is if I specify a quota for a user, how exact does that quota have to be? Can they write 1 more byte than their quota? Is that okay? How about a megabyte more than their quota? Sort of what's the granularity there? And of course, with UFS, the answer is, well, it's exact. You have your soft quota, and you start getting warnings, and you have your hard quota, and you just can't write any more above and beyond that. That, however, given sort of the asynchronous nature of ZFS, is very difficult to do to that exact level. So what we did instead was we said, well, we'll make it temporally sort of accurate, which is for a few seconds for the length of the transaction group, you may be able to exceed your quota.